Hi everyone. In this video, we're going to start to learn about how we can define our own data types. So to start off, we'll just define very simple data types. So the first one is just going to be a basic redefinition of an existing C type. And to do that, we can just use the typedef keyword. So for example, right here, this statement right here is defining a new type. So it's called counter T, and it is just an int with a different name. And we can see I have this little note. So the convention that your book follows is to use _T after any user-defined type, so even these basic ones, right, like this one. And so once we've defined a counter T like this, we can use it just like an int. So for example, after I have declared this, I can now declare a counter T variable here, and it's called flag. And just to show that this behaves just like an int, here's an example of using it in a for loop. And here you can see I'm just performing multiplication on the flag variable, and so you can see that it just behaves like an int. So the main use of this sort of thing would be just readability of your code. If you wanted to distinguish between a int that you use for one purpose and an int that you use for another purpose, you could declare it with two different names as two different types, and then it would be super clear in your code what those ints are being used for, beyond just their variable names. So you notice that in our programs at the very top, we always have our preprocessor directives, and then now that we have type definitions, we'll put those just below our preprocessor directives. The next thing that we'll look at is an enumerated type. And the enumerated type, so the syntax for an enumerated type is we're going to say, again, we're going to use our typedef, and then we say enum. And then after that, we're going to list almost sort of an array of identifiers here. And so I'll just use the one from the book. So there, the idea is these are identifying, I think, budget, places that your money might go. So I'll just type it out here. Useless. Oh, I forgot to actually name it, huh? So now we also need a name for this enumerated type. So this is saying my enumerated type expense T has the types entertainment, rent, utilities, food, clothing, automobile, insurance, miscellaneous. And these basically correspond to an array of values. So what's going to happen here is that entertainment is basically going to be a 0. Rent is basically going to be a 1, etc. And so I would define an enumerated type like this, again, for readability of my code. So let's say that I wanted to keep track of my budget. I'm writing a budget program, and I'm going to use an array to keep track of my expenses. And so I want in my, let's say, I'll say double, it's going to be a double array expenses. I have entertainment rent, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 different expense types. And I don't want to be remembering that expenses at 0 corresponds to entertainment, right? I would want to make that as explicit as possible in my code. But with my enumerated type, now, if I say, now I can actually use my subscript notation, but with the types that I have defined. So I could say something like expenses at entertainment plus equals, let's say I just went to a concert and it cost me $57.80. Maybe I want to first initialize this to all zeros. And so now maybe we might as well just check that this compiles and runs, although we're not printing anything out about our new enumerated type. But so this is much more readable if I can say expenses sub entertainment should get $57.80 added to it than if I said this, right? So that is one demonstration of how these enumerated types can make our code more readable. Another thing we could imagine is maybe our program is going to take in some IDs relating to our budget. So maybe ask user for budget category ID. And so this might be something 0 through 7 defined. So say my user knows that entertainment is 0, rent is 1, etc. And so maybe I say something like enter a budget category and then I'm going to get from them an integer and maybe I need to save that as something, so int budget cat, and so now I can save that as budget cat, and now I want to print the category of budget cat. So I could, suppose I had a switch statement here. Switch, I could do something like make my cases, so I'm going to ask I have a bunch of cases, right? I need to define them. And I could say if budget cat is 0, print what it should be entertainment, I believe. Let's go. Make this just a little bigger. Yeah. So I could print entertainment when case was 0, but again, it's more readable if I can do something like case entertainment. And maybe this is just the only one I'll add. And I need an F. And this is a colon. And this should be a colon, but maybe we'll say default other, just for now. So we could add all of these, but just for demonstration purposes, we'll try it out. Enter budget category. So let's say I do say 0, and I didn't have a new line there, so I'm going to add one. And let's just delete or comment this out for now because we don't need it. Oops. Okay. And oh, yeah, that is true. We didn't initialize flag, but that's okay. We'd like to just see this working. So there I entered 0 and I got entertainment, and there I entered 1 and I got other. So the point is that because I defined my enumerated type where entertainment is my zeroth item, I can write very readable code. So those are some basic ways that we can define our own types in C.